Hey guys, this is Fred from Pretty Fly Games, and today we're going to continue with our top-down car controller built in Unity. Today we're going to go through how you can add online multiplayer support to your game. This may look like it's running local multiplayer, but in fact it's running online multiplayer using Photon Fusion. So we're going to go through how you can set up Photon Fusion in various ways to get the best support for your type of game. But before we get started with coding, let's go through some of the theory behind it. So we're going to add multiplayer support, online multiplayer support in our game, and it will take you less than 10 minutes with a disclaimer that you have to maybe sit and wait for a while Unity updates and while you install packages, and without me talking. So it's a super fast process actually to just get something to work. And I've been looking at a lot of options, but what I decided to use is Photon Fusion, which I think is super good. This video is going to sound like a sponsored video by Fusion, but it's not. So with Photon Fusion, it is very easy to get started and to get something to actually work. So Photon Fusion is made by all the guys that made Pun, which is for Photon Unity, and it was made in 2011. And it was targeting 32 players, but when I was running it, I could maybe get 8 players to actually work without reaching their limits. And Pun, the bad part with Pun is that it's actually client authority, so that means all the clients are deciding what is going on, and it doesn't have a lot of features. And then they produced Bolt in 2014, and now they have just released Fusion in the end of 2011, which targets up to 200 players and has all of these cool features like tick-based simulation, and it handles authority rigid bodies. So this is a really cool upgrade, and this is what we're going to use. So before we jump into the code, there are some concepts that we need to go through. And you have a sort of a very big flexibility when it comes to using Photon Fusion, but it's slightly confusing if you don't know that much about multiplayer. So it can run in different game modes or modes. And the first mode is single player, so that's like for testing, and or if you just want to run your code without any multiplayer, you can use the same code. And the next one is dedicated server, and that's when you're running Unity without the graphics and stuff, and it's just a pure server. And then you have the client hosted, which means that one player is playing as the host and is the server, and then all the clients are connecting to that server. And this is with server authority, so it means that the server is in charge. And then we have shared mode, which is the easiest mode, and you have a bunch of clients that are connecting, and all of them are authority, and it's going over the Photon cloud, so it's very easy to stop, but it has some drawbacks. And then we have shared mode with a custom server, and we're not going to actually use this at all. So if we talk about the simplest mode, which we will be implementing first, which is shared mode. So what we have is a bunch of happy guys that are going to play a multiplayer game of our racing game. And what they have is the internet, the cloud that they are connecting to. So when this guy is sort of racing along with his car, and he's using his gamepad, we're sending everything that is happening on his screen, including the input, to the cloud, and then it's distributed to all of the players. And in this mode, all of the players are the authority, so they are the bosses for their own game. So what it means that it doesn't, this guy over here, he is only sort of listening to what is happening from the other players, and he's updating it. But he also thinks that he's the first that something has happened in. So if you have a racing game, it will be hard to know who exactly won. because this guy on his screen, he might have passed the finish line first. But it was only because he was lagging. Actually, this guy was the real winner, and on his screen it appeared that he won. But when you're trying to figure out sort of in the center here who actually won, then it will be impossible, because you can't look at this guy, you can't look at that guy. You can do some clever things like looking at, okay, what's the average of all the clients and what do they think, but that's fairly hard. So the same if you have a shooter game. If this guy is lagging, so when this bottom person is shooting, he's shooting at over here where he thinks he is, but in reality on his screen he's over here. So when he's shooting here and on this side he might get hit, and he's happy about that, but on this side he's not happy because he was in his world, he wasn't over here, he was here. So that becomes very confusing for the players. The bad part as well is that the clients can cheat because they're running their own code, so nothing can stop them from injecting something or doing something on the client, which gives them benefits. And if you want physics to work, this is not really going to work when it comes to collisions, because you're going to get some very weird behavior, and I've never found a way to really counter it. So if you're going to run in this mode, make sure that physics objects cannot collide. So what's the good part with this? Well, the good part is it's super easy to set up, so you can get started very quickly. So let's go into Unity and see how we can set this up. Now we're going to start with our spawn car scene that we created earlier, but we're going to change some things in it. We're going to remove the spawn car from the camera handler, because the online version will spawn the car from the network instead. And then let's save this as a new scene, and we'll put it in scenes, and we will call it online multiplayer. Photon only supports Unity 2020.3, so we need to upgrade our project. So let's do that. Awesome, so that was fast. Now we're on Unity 2020. So next thing we need to do is install the Photon Fusion package that you need to download from the Photon website. So the link is in the description, and just download it. While it's installing or importing, we also need to create an account. So you can go to the Photon website, the link is in the description, and it's free to use for up to 20 concurrent users. So that's fairly good as a starter. So once the package is installed, this dialog pops up, and you need to put in your Fusion app ID here. We'll use the one that I have for this tutorial. You can use it when just testing the code, but I really recommend that you get your own, because otherwise, if somebody else is running at the same time, you might get car spawn that you didn't expect. So once we've done that, just let's close it. So before we start the actual implementation, I just want to add a small disclaimer. We're going to do this quick and dirty way, and we'll just do the bare minimums to get something working online. So with that said, let's get started. We'll create under scripts. Let's make a new folder, call it network. And we'll start with making a new script. And the first thing we want is something called a network player. So as we're playing in a network or online, we want to be able to handle some network things on the player side. So let's open the network player in Visual Studio. So let's get rid of the update function, because we won't need it. And then we're going to use Fusion, because we're going to include some of its methods. And we want this to be our network player should derive, instead of from mono behavior, we wanted to use network behavior, which is from Fusion. And then we want to be able to handle events, and we want to handle the iPlayer left event. Now this generates an error because it says that we are not implementing an interface, so we need to react to that event. And the event that we're missing is the player left. So let's add that. And what we want to do is if the player is leaving and it is actually our object that is leaving, so it's the player's object that is leaving, and we're checking, okay, is the player equal to object.inputAuthority? So input authority means that this is actually the player that is sitting with the keyboard or gamepad and controls this object. So if this happens, we want to despawn this object, we want to remove it from the game. So that we use the runner.despawn and we pass in the object. So that's how we handle our player left when we are leaving. Then we want to handle the case when we are actually starting the game. So when we are starting the game, we are going to get an event as well called spawned. So when we are spawned by the network, then we are going to get this callback. And what we want to make sure when we get this callback is that, okay, are we actually the local player? Are we the are we the client that is in control? So are we the object input authority? So let's check that. And if we are, then we want to, well, let's add a little bit debug log so we can actually see what's going on. So in that case, we're gonna say spawned on car. And if it's not, then it means that we are another car. So a spawned other car. So we have our own car. That's our sort of local version of our car that we're controlling. But there are a bunch of other cars in the game. So this will be written when others are joining our game. All right. Then we want to have a function, or not a function. We want to have a convenient way of accessing our local network player. So we'll add a static and call it local with a get and set. So that way we can access this anywhere easily in the code. But we also need to assign it. So let's use local is equal to this. And I'm using a capital letter L, which I usually don't in my code, but Fusion is using it a lot. So let's stay with their way of writing code. Okay, so let's save this and return to Unity. Okay, so let's go into prefabs and duplicate our car. And let's call it car network. So this is going to be our networked version of the car, and the changes we're going to do later on to this is going to be slightly destructive, and we're just going to do it so we quickly can get into multiplayer mode, and it might even not actually work in single player anymore. But let's worry about that later on. So let's add our player that we created before, the network player. And this is going to say that, okay, there's a problem here. It has a network behavior and it requires a network object. So let's press this add network object, and automatically we are getting a nice network object, and it's checked with spawnable, which is perfect because we want to be able to spawn it. Then we want as well physics to work. So let's add a network physics rigid body. So rigid body 2D. So this is the one we want to add. And hello. Alright, so it wants to reload for some reason. Let it reload. Alright, here we are. And so this is pretty fine with the basic settings. However, we want to change this interpolate target. So let's open the prefab, double click it. And the interpolate target is a way of actually making the graphics look more smooth, and it should be a non-physics game object. Luckily, we placed our car sprite as a child to our networked object. So by dragging it here, we can actually get that feature, so it's going to look smooth, even though we might have some laggy connection or anything like that. So this is pretty much the change we need. But I noticed as well that the shadow, since it's not a member of our car sprite, is going to look a little bit weird over the network. So let's just drag it up here, so it becomes a member of our car sprite. So, and let's save our prefab. Okay, so now we have our network car, but we also need a way of spawning it. So let's go on the scripts and network, and let's create a new script, and we will call it spawn cars network. And let's open that in Visual Studio. So let's get rid of our update function, and then we're going to use a couple of things from Fusion and Fusion.sockets, and also system. So now that we have that, we also want to be able to react to certain events. And what we have is the central part of Fusion is something called network runner. So the network runner is like the heart of the multiplayer, and we want to be able to listen to its callbacks. So by adding this, we're getting a bunch of errors saying that, okay, we need to implement all of these different interfaces. And there are a couple of ones which are more interested than others. So let's start with our public on connect to server. So this happens when we are connecting to a multiplayer server. And what we want to do if that happens is we want to say that, okay, we want to actually check a special case and say that, okay, if we are running in the topology, which is simulation config and shared mode, then we want to treat it a little bit special. This is a special case. So let's just write it in the log to start with that, okay, we have on connected to server and we're starting player prefab as local player. And what we do here is we're going to spawn the local player. So we are using the runner.spawn method, and it takes in a prefab and actually a position and a vector, which is the orientation. And then we're feeding in that, okay, we are the runner.local player in this case. So now we're actually missing a couple of functions that I did before, but I forgot to include. So the first thing we want to do is have our player prefab, the cars prefab. And it's going to be a special one. It's actually going to be our network player that we created before that we're feeding into this. And then we have a function to say that, okay, we want to get some random spawn points. So let's add that one. And I messed up my formatting. Right, so it's going to return a vector 3. And what we already had since we created it before is the spawn points. So let's get our spawn points that we have in the scene. And then we are just going to make a special check to say that, okay, if we actually don't have any spawn points, then let's just start the car at vector 3, 0. But if we do have some spawn points, then we want to pick a random one. So we go like, okay, we're going to return out of the spawn points. We're going to use Unity engine.random because system has its own random. And we're going to say that, okay, take it from the range 0 to the full length of the spawn points. So this is just going to pick out a random spawn point and then we return its position. Okay, so now we got rid of all of those errors, which is great. So, but we have the case where we're not running in this share mode, and then we are just going to log and say that, okay, we have gotten on connected to server, so we are connected to the server. Now the second point, which is important that we want to listen to, is on player joined. So on player joined happens when we are when a player has joined a server, and the server in that case needs to make sure that, okay, am I the server, or are we actually the server? So we can check that and say that, okay, if we are the server, if the runner is a server, then we want to spawn another player. Okay, So in this case, we're saying that, okay, we are the server, we're spawning a player. And what we do is the same thing. We're gonna do runner.spawn with a player prefab, get a random starter point, just put it at upwards, and include the player that we're getting from this event. Awesome. If we are not the server, we're just gonna say that, hey, on player joined, somebody joined the session basically. Then we have a couple of other ones, which we are going to skip for now, where we can add them as stubs, so we can add them later. This one is fairly important, and we'll come back to it later. But for now, let's just skip that. And then we still have a bunch of errors, because we still haven't implemented a number of events. So let's just add them as stumps. So we have on player left, on input missing, on shutdown. In that case, we'll just add it into our log. On disconnected from server, let's add that to the log. On connect request, let's add that. And on connect failed, so we see what's happening. All the other ones we can just skip for now. So let's save that and go back into Unity. Okay, so now we have a script to handle the network player, and we can also spawn cars on the network. The thing we need now is some logic to handle the server or the host and server part. And we need to create a new script for that. So let's create a new script, and we'll call it network runner handler, because it's going to handle the network runner. So let's open that in Visual Studio. So the first thing we can do is get rid of the update, because we won't need that. And we need to add a couple of using statements. So we're going to use Fusion. We're going to use fusion.sockets, Unity Engine Scene Management, threading tasks, system, and system link. So what we need to do is we want to be able to get a component that is our network runner. So let's add that under other components. So we want to have our network runner. And how we handle this sort of network connection part is that we need to start a network runner. And that is a little bit complicated, but we were going to use a task called initialize network runner. And it is giving us an error here, because we need to do certain things with it, since we need to await it, etc. But we can ignore everything right now and just say that, okay, it's a task. It's called initialize network runner. It takes in a network runner, a game mode, network address, scene reference, and an action called initialized. Then what we need to do when we have this is that we're gonna check if we have something called network scene object provider. So this network scene object provider is something that we have inside Fusion to be able to handle network objects that is already added in a scene. So we want to make sure that this already exists. And if it doesn't, it means that we actually need to create it. So we just check that, okay, if this is null, then we are going to do a runner.gameObject and add a component called network scene management default. Okay, so now we know that we can handle static objects as well in the scene and not only the dynamic cars. What we want to do then is we're going to call a function in the runner. So we're going to say runner start game, and with new start games arguments. And we're going to say that, okay, we're going to run it in the mode that we have provided up here. We're going to run it in the address that we have set here. And we're going to run it with the scene that we have provided here. And we're going to call it race room, and it's going to start in a state called initialized. And then we have our scene object provider, which we have created here. Okay, so perfect. What we want to do now is when we fire this up, we want to start our client. So in our start function, let's add the initialize network runner as a task. And we provide our network runner that we have here. We are going to say that we're going to run it in shared mode, because that's the easiest way, so we start with that. And then we're going to say that we're going to run it with the network address of any. And our scene management, we're using our build index. So we're checking which build index does our scene have. So it needs to be included in the build part. And then this will be shared with all the clients so that we are sure that they are running the correct scene. And the interesting part with this shared mode that we're running now is that the clients are actually deciding, am I the first client? And if I'm the first client, then I'm actually going to act as a sort of a host. And all the other clients that are connecting are going to be clients. So we actually don't have to specify anything at this point if we are a host or not. And since we're running it in shared mode, it means that all the clients will actually be sort of the bosses of their own world. So they are deciding that, okay, I have authority, so I decide what is going on in the world. So my network runner, we need to make sure that we actually assign that as well. So let's add that in the awake function, and we will just get the component network runner, so it needs to be attached to the object, and we're using get component network runner. Okay, so let's save this and go back into Unity. So now we have all the scripts that we need to run our online version of this game. So let's create a new game object, and let's put it on position 0, 0, 0. And let's start by adding our network runner handler, and on the same object we'll add our spawn car network, and let's just rename this to network runner and spawner. And this one, spawn cars, takes in our player prefab, so we need to assign our networked car prefab. And we need as well to actually look at this one and see what it has, car networked. So let's look. Okay, we have the top-down car controller, which is fine. We have input, which is good. And then we have our ghost recorder. So let's get rid of that, because we're not going to handle ghosts when we're playing online. And then we should have everything that is here is okay. But we need as well to change our top-down car controller. So let's select that and open that in Visual Studio. So let's scroll down, and what we want to change here is this fixed update, because we're not going to run the regular fixed update anymore. We're going to run a fixed update network, which is the same as fixed update but for networks. So let's change our description to frame rate independent for physics calculation but networked. Okay, so as well, what we need to do is we need to change this, because it needs to be derived from network behavior. And let's see, so we get an error, and that's because we are not using Fusion. So let's start use Fusion. Oops, using Fusion, and then that problem will go away, and the other problems as well. And then we can just see that, okay, there's an error. So this one needs to be public actually, or a warning. And I think, oh yeah, public. Yeah, this is specific for Fusion. So it needs to be public override and void fixed update network. Okay, so now let's save that, and let's go back into Unity. Okay, so now there are two more things we need to do. The network runner and spawner has the network runner handler and the spawn cars, but it's missing a component, which is the actual network runner. So let's find that. Here we have the network runner. And then we also need to include our scene, online multiplayer, in the build list. And let's move it up, so when we compile this, it will be the first scene that is loading. Okay, so if we save our project now and press play, then it should actually, well, hopefully work anyway. So we have our network runner started, and we can see that, okay, something happened. So it changed our network runner and spawner into a don't destroy on load, which is fine because we want this to actually run all the time regardless if we are changing scenes. And we can see that, okay, network runner, it's in the state running, and it's in client mode shared. We actually have a car as well, and we have a network physics simulation 3D, which is not correct, and we also have an error saying that network rigid 2D found while physics mode is set to 3D. So it means that we have not made our configuration 100% properly on the Fusion side. So let's stop our little game again, and we'll clear the logs, and let's go on Fusion and real-time settings. No, actually, Fusion network project settings. And let's open the config. And here we can see that the physics engine is set to physics 3D. So we want to run physics 2D. So let's save that and press play. And after this, we should hopefully not have any more errors. Oh, we need to apply it as well. Sorry. So server network runner started. I actually added this log before. Oh, hold on, it didn't actually save. Ah, apply. I forgot to press the apply button, even though it asked me if I would like to apply it, and I said yes. So let's try it again. So I've added the debug log server network runner started to this file just to make sure that it's running. And now we can see that we're getting our event on connected to server starting player prefab as local player. And we can run around with our car. So how do we know if it works? Well, let's build our client from this. So we'll go into build settings. And let's actually change something. So in player settings, let's change this from full screen mode into windowed mode, so I can resize it and see what's going on. And then we can build a couple of clients and try it out. So let's build, and let's add a folder, call it PC test, and select folder and let it compile for a while. So let's skip until it's done. Okay, so now that we're back, let's fire up our main client in the editor, and while it's starting, let's as well start a couple of additional clients. So I'll start a few top-down car controllers, and I will actually move them off screen, and then we can start a third one, move it off screen. So now we can see that we are actually having 3 cars, and one of them, that one, is mine. So we can see that, okay, I can run my own car, which is the one attached to the editor. And then I can take one of the clients, I'm not sure which one, this one. And I can run around with that. So this is a very sort of dirty way of doing the multiplayer, because it's ignoring some of the features of Fusion, but it shows that, okay, we are actually able to create a multiplayer game very quickly, and it's using physics, and it's synchronizing the information between the clients that are connected. Now, since all the clients are authoritative, we have this big problem when cars are hitting each other. So we can see that, okay, if we are colliding, then the actual collisions are quite large. And the reason why this happens is because all the clients are deciding what is happening. So this little car here is saying that, okay, I'm colliding, but I'm the boss, so I'm the strongest one. And then that client is saying that, but hey, something happened here and I'm the boss. So everything is sort of weird when it comes to collisions. But one easy fix for this is to disable physics so that the cars cannot collide with each other. Otherwise, if they are required to collide with each other, we can't run in this mode because we're gonna have so much problems. So that's when the authoritative part comes in, when we have another structure. So let's go back into the theory and I will explain the difference. So the next mode that we're going to implement is the host client mode. So in this case we have our 4 friends that are playing this game over the internet. But the difference is that we only have one host that is the authority. So he is the boss. He is deciding what is happening, and all the other players are not the bosses. So it's less of a problem if you're a lot of players. And the pros with this is that the physics and collisions will work because it's only simulated over here, and the host also knows who won or who shot who because he is deciding. The host can cheat by injecting some code here, but the other clients they can't cheat as easily. Of course they can analyze the screen, etc., but it's not the same. The bad part with this setup is that the host might have a bad connection, which influences everybody else in this game mode. So how it works is, let's say that this player is moving his car, so he is providing some input, and in this mode the input is only sent to the host. So in this case we're saying that okay, he's pressing the accelerator on his gamepad, so that information is sent to the host. The host will then run the simulation here and say that okay, he is hitting the acceleration button and therefore his car should move. And then he sends that information, the host sends that information to everybody else, like okay, the car has now moved, or the car has slammed into another car, and because of that 2 of the cars are colliding, and this will happen then. So the host will send that information back to all of the clients so they can understand what's going on. But what you can have as well is client prediction. So when this guy is actually starting to hit the accelerator button, then that car can actually move a little bit on his screen, so it doesn't appear that it's lagging, even though it takes a little bit of time before the server is actually acknowledging and say that hey, your car is actually moving. So that's a way of reducing the lag and making sure that the player is feeling in control, even though that it's the server or the authority here that is deciding when his car is moving or not. So let's go back into Unity and see how we can implement this mode. So to implement the host client mode, the first thing we want to do is change it in the network. So let's go into our network runner handler and open that in Visual Studio. So the first thing we're going to change in the network handler is the game mode. So when we are initializing the network runner, we are saying that, okay, we want to run in shared mode. So let's change this into auto host or client. So that makes the first person that connects to a game the host, and all of the other players are going to be the client. And this is with the server or host authority, so physics and everything else will work. But as I explained when I talked about the different modes, we also need in this mode, for it to work properly, provide input, because that's the whole key, right? So we wanted the clients to provide their input to the host so it can calculate all the physics and stuff like that. So what we're going to do is we're going to say that okay, our runner is provide input is set to true. So let's save that and go back into Unity. Now to handle the input we will need a new script, or actually a new struct, and we will call it network input data. So let's create that and open it in Visual Studio. Now the first thing we can do is get rid of all of the start and update, because we won't need that. And we will actually be using Fusion, so let's add that using Fusion. And we will not derive it from mono behavior, because it should be a iNetwork input struct. So let's change our class here into a struct instead, because this is how Fusion wants our network to be represented, or network input. So let's do it that way. And we're going to do it in a very easy way. We're just going to take a vector2 as direction. This is not the most efficient when it comes to networking, because we're sending 2 floats, which can be very large and sort of, well, large in network terms at least. So it could be smarter to just send a bit saying that okay, the user is pressing up or the user is pressing down. But for now, we're just going to keep it simple. So let's save that and go back into Unity again. So let's go into our car and input handler and open that in Visual Studio so we can modify it so it can get network input data as well. So let's open it in Visual Studio. So the good part with our car input handler is that it's already collecting information in vector 2 that we can use as well for the network. So we actually don't have to change anything here, but we want to have a new method or new function that gives us the ability to actually get the network input data from our car input handler. So what we take is that we take our struct and we create a new input data, and then we will say that okay, the direction of this is going to be our input vector that we already had, and then we will simply return it. So we do a return network input data. So now that we've done that, let's go back into our spawn cars network. So I already have it up here, so I don't have to exit into Unity. So what we want is this code already has the event on input, so that's going to be requested by the server, and it's going to say, okay, give me your input for your player. So once this event is triggered, we need to pass back the input. So what we want to do is we want to make sure that we're getting input from our car, which is our local car, or the client's car. So we will reference the component and we will use our car input handler, and we'll call it local car input handler. So when we are getting our on input, what we will do is we will make sure that we can access it and that it's actually spawned and everything's ready. So what we do is we make a little bit of a check and say that okay, if our local car handler is null, so we don't know who the local car is, we haven't assigned it yet, and our network player is not null, so it means that the network has received a local player and we know who we are, then we can actually try to fetch our nice component. And how we do that is using our regular get component, and we can use network player.local and get component and get its car input handler. And then we just want to make sure that we actually really have it. So we are checking again, is it assigned? Has local car input been assigned, so it's not null anymore? And if it is, then we're gonna pass back our input in this struct that we have received here. So we're gonna use input set, and then we'll just get our network input. And that's it. When we're doing this, then we're passing back the input into the server. So we need as well to make a change to the top-down car controller, and this right now is using the local input, which we don't want it to do really. We want it to use the server input. So what we do is that we're going to say, okay, if we can get the input, the network input data as data, if there is any input, then we're going to actually use that. So this says that okay, returns true if there's a valid iNetwork input can be found in the current simulation tick. So it means that we have received some information from the server, and we want to use that instead of our local input. So what we do is we're saying that okay, our steer input is going to be our data.direction.x, and our acceleration input is going to be our data.direction.y. So if we save this and go back into Unity, everything should actually work now. So let's start our game, and let it load, and then we have spawned our car here, and we can see that yeah, it's still working, so that's perfect. And then I already built a client, so I'm just gonna start that up. And so now we have another client connected to the host. And as we see, our local player here is working, and the other player is as well working. And the good part is that we have, fixed collisions. Now we have the host authority, so it's actually simulating on only the host, and the inputs are being sent to the host. So that's actually very cool. We can see that the physics are working perfectly. I can't really tell the difference what's the online version and what's my local version. So that's pretty cool. And I've tested this with some lag as well, and it performs very well, I would say. So that pretty much is what we wanted to cover, but we will make one little change, and that is it's quite confusing that all the cars have the same color. So we're going to change that to make sure that we can differentiate between who is your local player and who's the remote players. So let's go into our top-down car controller and open that in Visual Studio. So we already control our sprite renderers. What we will do is we will add a multiplayer header, and we will include a sprite called remote car sprite, so we can send in a different sprite. And then we're going to save that, and let's go into our network player. So this code here is acting when we are spawned, then we're checking, okay, am I the local player? And what we want to do in this case is that, okay, if we are actually not the local player in this case, then we want to do something different. So let's fix the code. So what we do is that we're going to say that, okay, we want to actually access our top-down car controller, and we know that it's attached to the same game object, so we can just use get component of it. Then we are going to say that, okay, you know what, we want to change the sprite. So the top-down car controller, car sprite renderers sprite is going to be top-down car controller remote car sprite instead. So this will make it appear different. So let's save that and go back into Unity. So if we start our game now, we will get our red car as before. And it's ready. All right, there we go. Here's the car. And then when we are starting up our client, we should have a blue car appear. All right, so here the red car is our local player, and we have the blue car, which is the remote player. So that's what we were planning to cover. Now you can add multiplayer support in your game. Of course, this is the easy part, to get everything to run in this mode, but everything else like selecting cars and the UI and ability to chat, etc., that's a whole other chapter, and that's not something that we will cover today. But I hope that you enjoyed the video. Please give it a thumbs up, and also hit that subscribe button if you want to get a notification when new videos are out. I'd also like to give a special thanks to all of our Patreon supporters, and especially MSGS Europe, that has reached the WoW level in our benefits on Patreon. The link to our Patreon page is in the description below, so please consider supporting us there. Here's an example from our game, Total Arcade Racing, which uses this component for its physics, inputs and other powers. You can find the game on Steam, Xbox and Nintendo Switch. Please take it for a spin if you want.